Hello friends, it's Jiftesh from Learn Coding Hub. This is the first tutorial within the series NumPy tutorial series, and in this one we will have a quick introduction to the NumPy, that what NumPy is, why we use it, why we need it when we have a Python list, and then we can see some the basic commands or the attributes of the NumPy so that it get us ready for our next tutorial where we will look into more detail about the NumPy. So let's begin. So the very first thing is, what is NumPy? So NumPy is a Python package which provides us the multi-dimensional array, ND, also known as ND array, and dimensional array, and it provides us lots of routines to do the fast operations on the arrays, including like the mathematical, logical operations. We can do shape manipulations like transpose, we can do sorting, selecting, and lot more, which we will be covering in this series a lot. And that is one of the reason it is used in a lot of scientific calculations, in the programming methodologies, in lot of machine learning. And so yeah, lots of good stuff coming. So let's first of all try to understand what we really mean with ND array, n dimensional array. So of course n is number which increase from 1 onwards. So very first one is the one dimensional array, also known as 1D array. So within the NumPy, with each dimension we call it as axis. So for example, this is one dimensional array, it is having one direction, or you can say one axis, and each of the values are known as elements. So this particular array is of shape 4 because we have 4 elements in one direction in one axis, so it's not a one-dimensional array. Then let's quickly look into the two-dimensional array. So in the two-dimensional array, so you can think this like as a table. So we have a rows and we have a column. So rows are like axis 0, the columns are axis 1, and then this is, as you can see, of shape 2, 4, 2 rows and 4 columns, of course having the values from 11 to 18. Then the next one is three-dimensional array. So within three-dimensional arrays, again you have rows, you have columns, and then you have depth. That's why you have the axis 0, 1, 2, and this particular array, which is of ones, is of shape 4 rows, 4 columns, and 2 depth. So as you guys can see, that is a reason where 1, 2, 3, yeah, it's n, it can be any dimensional, and that's a reason it is used in lots of scenarios based on your what exactly you're working on. Okay, the next question is, why to use NumPy over Python list? Because we have a Python list, why we really need NumPy? So I would say the most important answer is, it is blazing fast. Just don't trust my words, let's see it in action. So what I have done is, I have quickly wrote a very small code so that we can compare the speeds between the Python list and NumPy array on processing, on mathematical operation processing. It's a very simple one. So if you don't know about, of course, if by NumPy right now, trust me, you don't need to understand this code in detail. This is just a speed test. I could have shown you the result, but I always want to show you what exactly I'm trying to do here. Okay, so first we have imported time and NumPy, and then I am creating a normal Python list. So you can see list 1 and 2, and all it doing is taking from range. So basically this list is from 0, 1, 2, 3, 4 up to the 1 million. And what I'm doing is, I am starting the time before I start the operation. Now within the Python list, we can't do the mathematical operations, like I can't just multiply list 1 and list 2. That is another reason you will see, because of this mathematical operations, the ease that we can use in the NumPy, that is the reason we use the NumPy. But it's not only the ease, it's about the performance as well. That's what we are checking right now. So basically, if we have to do the same operation within the Python list, then we will be doing the for loop, and then we are multiplying each elements, and then we are of course appending into the array. So then we are printing how long it took. And then same thing we want to try, want to do in the NumPy array. So I have used numpy.arrange. Again, guys, don't worry about what it is arrange. In our next session, we're going to look into all the methods, the way we can create the NumPy array. So one of that one is arrange, where we can give a range. Basically, I'm saying up to million. So the NumPy array would be 0, 1, 2, 3 up to million. Okay. So I have got NP1, one array and second array, and I am starting a time before I do the multiplication. And you can see it's very easy in the NumPy. All I can do is NP1 times NP2, and it will give us the multiplied version. Okay, and then I'm recording how long it took. Okay, so let's have a quick look. So if I go and do Python, my file name is speedtest.py, and let's run it. Okay, as you guys can see, the Python list multiplication took us 0.22 seconds, and the NumPy multiplication is 0.002. So let's increase it. Let's try to increase the, let's try to make it 10 million and see. You can already see the speed difference, but let's increase it up. Okay, now let's run it again. Gonna take a little bit of time. Of course we have, yeah, okay, now you guys can see the Python list multiplication is taking us 2.2 seconds, whereas the NumPy multiplication was 0.015. Guys, see the difference. And we're doing the same thing, but it is a blazing fast. And imagine you are working on these the models where you have the million of record, and it's not only one time, you're running thousands time in a day. How much the impact would be on the computer processing and the time. And that is a reason it is used massively. Okay, so I think that proves it is a blazing fast. Then the next is why it is fast. Yes, we understand it is fast. We saw it in action, but why it is fast? The first reason is that the NumPy array elements are required to have the same data type. Of course, there is an exception to the objects, but otherwise all the elements you will specify, or it will have a data type. So all the elements would be int 16, int 32, float, so because it is the same size in a memory, and the Python doesn't need to do the type checking at the runtime, and that's the reason it shows the performance of quite high. The other reason is the NumPy array are contiguous. So what does that mean? It means that in the computer memory, the values are next to each other. Let's understand it more. So let's say we have a 2D array with shape 3x4, means 3 rows, 4 columns, and I have color coded each row with different colors, so you can see the difference. So basically the way it is, these values are stored in a memory are next to each other. So there'll be first row, then there will be second row, then there will be third row, and when computer reads it, it is a lot quicker from the performance point of view reading just next memory block, because it is know where it is. Whereas in a Python list, it doesn't work this way. In Python list, these values would be scattered in a memory block, and then there will be table pointing to the address of that one. So then Python needs to read the memory address table first, and then see that, okay, where it is pointing, get the values. So that involves time. Whereas here, each and every value within a memory block is next to it. So within NumPy, we use two types of contiguous, C contiguous, F contiguous. I will not go in detail, but C contiguous is row based, F is a 410 which is column based. So with a row based, if I'm doing any operation row wise, because within the memory it flattened the NumPy array, so it is very, very quick, and we saw that one. Okay. And I mentioned about the mostly. The reason it is that because when you create an array, they are contiguous, but if I transpose this one, which is basically more converting rows into the columns or columns into rows, so that will, then the array will become non-contiguous, and that's the reason I mentioned about the mostly, but most of the time you will use the contiguous one. Okay. And then the third reason it is blazing fast is because of the pre-compiled C code. Now in the Python list one, we wrote the for loop and we're doing that operation within a Python. Now with the NumPy as well, behind the scene it is using the for loop, but it is using the for loop within the C codes, which is the pre-compiled C code. That is the reason it is very fast. For any element by element operation, it is done by the pre-compiled C code, and that is the reason NumPy gives us the performance very near to the C. Okay, so I think guys you are pretty much now convinced that and know that NumPy is fast and why it is fast as well. So now let's look into the other reasons to use the NumPy. Yes, okay, we got it. It is really fast. Then the other reasons are, like I mentioned, we can do a lot of mathematical logical operations. We can do shape manipulation, sorting, and a lot of other things which we will see in the coming lessons. So which is not possible with a Python list. Yes, you can do some of the operations with for loops and all those sort of things which are not effective, or they are not performance wise as well. Plus it's not easy, you have to write that code as well. So with NumPy we get that one. We can do, I've given a very simple example, but we can use a lot of complex operations very quickly and very easily, and performance wise very quick. Okay, so that is the one reason. And the other reason is the NumPy package is used in lot other Python packages. For example, pandas, scipy, tensor. To be honest, pandas uses the NumPy as a base behind the scenes, and so many other packages as well. And then they are fully integrated with the packages. So when you're working on the machine learning project, you're working on tensor, you will be able to use quickly the NumPy linked to matplotlib if you're doing the visualization. So there's a lot of things, and that is the reason NumPy is so famous. And to be honest, maybe that is the reason you guys are here today and trying to learn about the NumPy. Okay, so before I conclude the introduction section, let me quickly give you some of the basic attributes of the array, because this will set us as a base for our next lessons, and then we can quickly go through. So what we will cover in the basics one today is how to find it out the dimension of an array. So we can use ndim. Just hold, we will do quickly in action, but let me quickly tell you what we're covering, and then we can see the shape, so the size of an array in each dimension. So for example, if you have n rows, m rows, so like I shown you in the previous picture, so we can see the shape. It is like 2 by 3 or something like that. So we'll see in action. The next one is the size. Now the size is the total number of elements in an array. So for example, if you have an array and you want to see how many elements are there, so you can do quickly with dot size. And the last one we're going to cover is the data type. So you can quickly see what is the data type of all the elements within an array. We know they are homogeneous, they are all same, but what the type is, we can check that one. Okay, let's quickly see in action. Okay, let me clear this. I'm going to go into the Python. Now let's create array. So I'm going to create np.array, and let me create two-dimensional array and 3 and 4. Okay. Oh, sorry, I haven't imported the NumPy. Okay. By the way, sorry, I should have mentioned it. If you are totally new and haven't installed the NumPy, you can of course install by pip install NumPy. That way you can install it. Okay, so once it is installed, then we can import NumPy as np, and now I can run my previous one. So if I do print a, and then you can see it is the array. Now let's run those ones. So let's first of all see the n dimension, how many dimensions it has. So a dot ndim, yeah, it is two-dimensional array. We can see there are rows and columns. And let's see, and then a dot shape. As you can see, it is 2 rows, 2 columns, and then we can check a dot size, how many elements are there? There are 4 in total. And then let's look at the data type. So a.dtype, what is the data type of the elements? It is integer 32. So if I change, so let's say I create and I give the d type is equal to float, and I try to print, and then if I do d type, you can see float 64. All right guys, that's it in today's introduction. I just wanted to cover what NumPy is, why we use it, and just some basic attributes. Now in our next lesson we will see what are the various ways to create the NumPy array from the existing data, from the new data, and lots of further tutorials within the series to see the full potential of the NumPy and how it is used within our data analysis and data scientist being you. All right, thanks guys, speak to you soon. Cheers, bye.